Hello everyone, my name is Parth Trivedi and I'm currently doing a data structure and algorithm review of GATE exam questions. Here I have given the six question to solve it and present the answer of it. So let's start. So here my first question is the consider the following is true. Okay, t of 2n is equal to 2 3 in bracket root n plus 1 where t of n is equal to 1. So the option we have given, and according to the options I think option C is a right answer, cause time complexity of recursive function t of n is equal to the given function. By applying the Master's theorem, the theta of n in the Master's theorem, we have n is equal to size of input, a is equal to number of subproblem in recursion, n by b ratio is the size of each subproblem, and further we can see that all subproblems are assumed to have same size, and f of n is a function that cost function of work done outside at recursive call. So so the final answer of this question is option C. So our second question is the median of n elements can be found in order of n time. Which of the following is correct about the complexity of quicksort, in which remain is selected as pivot? So here we have given the four options, and the option C is the correct answer, because when quicksort is implemented using the median of elements method, the median of element is selected as a pivot. In this case, the time complexity of quicksort is generally n raised to 2. So here the correct answer is option C. So our next question is, here we have given the two arrays which where each number is either 0 or either 1. So the question is, what can be fastest algorithm to find the large span in terms of I and j, such that a1 element plus a1 plus 1 element up to a jth element is equal to b of 1 element plus b of j plus 1 element plus b of j element? Or we can simply, in other words, we can say that report that there is no such span. So here we have given the four options. In these questions, the correct answer is option C. So let's start uh, doing by answer by option A. In option A, order of n in 3 raised to n and big omega 2 raised to n. Option A, time implies an exponential time complexity, and it doesn't provide fast solution. Option B, in the key comparison model, option B is not a standard algorithmic complexity for this problem. And option C is only sum of two an element is even doesn't offer a generally applicable solution for this problem. So this particular question, the answer C, it takes theta of n time and space. So our question is, consider the following code written in pass by reference language like Fortran, and this statement about the code. Here we have given the code and some statements. So in this statement, which of the statement are correct, we have to find out. So the correct answer is statement S1 and S4 is correct answer. Statement 1 says that the compiler will allocate the temporary variable for ib plus 5, which is 13, and pass its address to swap subroutine. And the statement 4 is saying that the swap subroutine will be swap the values in I of a and temporary variables. So I of a becomes 13. The value of I of b remains 8. Hence, the program will print 13 and 8. And there are no runtime error in this code. So the S5 is not possible, and that's why only two statements S1 and S4 are correct. So our next question is: the height of a binary tree is maximum number of edges in any route to leaf path. Maximum nodes is binary tree of height h is. Here we have given the four options, and option C 2 raised to h plus 1 minus 1 is the correct answer, because the maximum number of nodes in any binary tree of height h is given by this formula. So this is the formula. This is a very simple question, and so the answer is option C. So our next question is: what can be maximum number of binary tree that can be formed with three unlabeled nodes? So here we have given the four options, and the correct answer is option B. So here we have the equation that can directly tell us what can be the output. So the equation is like that: C of n is equal to, in bracket, 2 of n factorial upon, in bracket, n plus 1 factorial into n factorial. So let's assume n is equal to 3, because here in question we have 3 unlabeled nodes. So after performing the certain calculations, for this case we have seen the answer is 5. So the last answer is 5. So here I have tried to solve the problem which have given to me, presented by me, Parth Trivedi. Thank you.